All right. Welcome one, welcome all to the LeetCode stream, the official Reddit LeetCode stream. No, it's not official, but it's official to me. So let's go ahead and get started here. Always typing what I start off with. So welcome one, welcome all. Always like to leave a link to the YouTube channel in case anyone wants to check that out. So some quick housekeeping like we always do. So for anyone watching the first time, I think the best way to get started is really just head over to my YouTube. I have like a channel introduction there and it tells you like my intent of everything that I'm doing, why I decided to start doing all this. But the gist of it is I wanted to start developing a LeetCode habit. And so I made all these videos that essentially take you from having solved no problems to having solved some amount of problems. And if you've been following with me since the beginning, then we've done 40 questions, which is pretty insane. That's pretty awesome. I'm very happy about that. So I hope this has helped some of the people that are watching. It has certainly helped me. Even tomorrow's going to be a week that I've been doing this, and I've certainly gotten better. So if you feel like you're struggling or you're plateauing on your progress, I promise you can get better because I've been there. That feeling that, I'm not doing well or I can't get better. And with consistency comes the results. So keep it up. Sweet. So I left the YouTube link on my channel. I upload all these streams to there. And like I said, you can start from the first video and go all the way through. And now I do have this channel introduction, which again will walk you through the intent of this stream and sort of give you some more direction. So without further ado, one of the things I want to talk about is we left off yesterday in a problem that has been a doozy for me for a long time. But I'm happy to report that I figured it out. So I'm very happy about that. And I figured it out in linear time, which makes me even happier. So I want to go over this right here, count number of pairs with absolute difference k, and I want to talk about how I solved it. There's something that I learned from a friend of mine who is in the Discord that I run, and one thing he mentioned was like really try not to look at hints or answers and just mull over something for a while. That's totally fine and probably better than just going straight to discussions or hints, really thinking about it and struggling with it. And I did that, and I drew many things on the whiteboard, and I finally got the answer. So let's think about this question here, right? Really, we're trying to find all the unique pairs in this array where there is a difference of this k that they give us, 1. And we know, like for ij, I needs to be less than j. So anytime we find a pair, like it can't go, even though it looks like it's sort of going like, oh, 2 to 1, that's a pair. Okay, that's cool, right? But the I always needs to be less than the J. That's how I took it. Like the current pointer that we're at needs to be less than the pointer where the match is. And one thing that there's this pattern a lot in LeetCode where you iterate through an array, do something with the data you have retrieved, and then add the current item to that data. So what does this mean? There's a very common pattern where let's say like we start at 1 and we have some like data, which I'm going to actually start working on all this now, right? I'm going to create a map called counts. And this counts map, this counts object literal, is going to hold the frequency of numbers. Like at 1, it'll have, 2 by the end, 2 will have 2, so on and so forth. This is the sort of like the do something with the data you've retrieved. So we're at 1, we look at the counts, we do something with what's in counts, and then we add 1 to this array. So at any point in time, right, we want to see if they're like we're at number 1 and we say, okay, is there does there exist a pair that is either 1 plus k, which in this case is k is 1, so 1 plus 1, 2. No, there isn't. Like there is a 2 in here, but we haven't seen it yet. So by not by like only processing these items one at a time, whenever we get to some item, we know what we've already seen. So it's sort of keeping track of the things we've seen and only adding the current element after we've done whatever we want to do with the things that we've seen. Hopefully that makes sense. But let's go through with it. So let's kind of start the whole algorithm again, right? We're at number 1. We say, have we seen something with 2? No, we haven't. Have we seen something with 0? No, we haven't. But now I can say, well, at this exact moment, I do have a 1, right? And now I get to 2. Let's say my I is at 2. So I ask myself, have I seen 2 plus k, which is 3? No. Have I seen 2 minus k, which is 1? Yes, I have. So now the amount of matches I have is 1. So let's keep matches here equals to 1. And now I say, at this point, I've seen 1, 2. Now I go to my next 2. Have I seen a 2 plus 1? No. Have I seen a 2 minus 1? Yes, I have. I've seen one before. So now matches is 2, and now I've seen 2 2s. Now I get to the last one. Have I seen a 1 plus 1? Yes, that's a 2. How many 2s have I seen? I've seen 2 because that's what our array holds right here. That gives us 4. Have I seen a 1 minus 0? No, I don't. I is out of bounds, and there you go. Now we have exactly what we need. So what we can do here is we can create this const counts, which is going to be an object literal of the frequency of the counts of the numbers that we've seen so far. And then we can have a matches variable that will keep track of all the different matches that we've seen. So now I can say for const n of nums, what I'm going to do is create a positive, and I'm going to set this equal to n plus k, and a const negative equals n minus k. Right? So this will give me the positive thing I'm looking for and the negative thing I'm looking for. Right? So what do we do? If counts at positive is not equal to undefined, right? So let's say if I'm at 1, 1 plus 2, have I seen that one yet? No. Right? But if I have and it's not equal to undefined, then we can say matches plus or equals counts at that positive one. Similarly, if counts, I'll just copy this whole thing here. If counts at negative, not equal to undefined, then we can do this. And now, really, we say counts at n is going to be equal to counts at n plus 1 or just 1 for the first time that we set it. So let me remove all this stuff, and we can return matches here. And let's run this to all the different test cases. 403 and 403. There was another test case I tried before. I wanted to do 5, 4, 3, 2, 1 with 1. 4034, 4034. We submit this. 23.05. This not having premium has really, again, I say it almost every stream, but I've been spoiled with premium because I tend to want to spam that number. 41.71. So I do notice that a lot of these are trending, sort of like mid-range. So there's probably something I can do to make this faster, but I'm pretty happy with this algorithm. Let's see. 41.71. And try like one more time. 95.62. So let's see what the discussions here say. Let's look at the top one, counting sort, of course. Since nums I is in, we can count each number using an array. Now we can sweep the counts and accumulate the product of k minus apart counts. Yeah, I guess that can probably make it a little bit better, right? Because we're just doing nums out length is 200. Is he also creating count 101? Yeah, we can create like a static array that will essentially be the counts that we have here. So let's see if we can actually do that. Let's see if we can make our answer a little bit better. So we started off with this object literal, but if we just create a contiguous array, so new array of 101, and I'll just, actually, do I even need to fill it? I don't really need to fill it, right? Let's see. No, I'll fill it. I'll fill it with 0. And now I don't even need to worry about this because it'll either be 0, right? So we can say, let's remove this counts here. And now we have this. So nums at I is less than or equal to 1. Now, the numbers, oh, and we don't even need to do, I see what we're doing here. As I'm going along, if I've seen one, although this one will be a little different because, well, const n of nums, if I've seen positive or negative. I guess it's really going to be the same thing. Counts at positive, counts at negative. At the end, we can just say counts of n plus plus. What is this going to return? 4034, 4034. 98. So the first one right off the bat was already like better. So that's very interesting. Let's try this again because last time I did it a couple times. 26.09. But I think theirs 77.71 plus plus count n for int I, k plus 1, I less, best plus or equals count I times count of n, I minus k. I didn't get it. How did this approach come to mind? A lot of people aren't understanding it. It's rated as the highest one, but it seems like a lot of people aren't understanding it. I do want to see some other ones here. Yeah, this is very similar. This is very similar to what I did here. So I like the one I came up with. I think the counting sort is pretty, I don't know if it's how intuitive it is. I think it's a good answer, but I'm happy with this one because again, I worked through it and that's the most important thing, right? Working through these questions and like really trying to get them. So this, we went over this yes in yesterday's stream, but I really wanted to start off this one with this one, this stream with this question, just to make sure we covered it. So let's get to the next one here. Count number of pairs with absolute. Okay, so check if two string arrays are equivalent. Given two string arrays, you know what I'm going to do? Like for anyone that's watching, I think I should be a little bit more. I normally only do this once, but like for every question, I'm going to link it to the leak to the chat as well, so you can like click on it and see it. Because I realize that this stream isn't intended for mobile users, and I realize that probably a lot of you are watching this on mobile. There just isn't a great, like there isn't a very elegant way for me to do that because LeetCode's mainly for mobile, or not for mobile, for desktop usage. So I'm trying to link to the question so you can view it on your own. And then of course, I do have to say like, if you want to watch this later, you can always visit the YouTube and you can watch it that way and hopefully get a lot more from it. You can watch it in full screen mode. Okay. Check if two string arrays are equivalent. Given two string arrays, word1 and word2, return true if the two arrays represent the same string and false otherwise. A string is represented by an array if the array elements concatenated in order form the string. Okay, so they, I mean, we could, I don't just want to do like a blind concatenation, but I can't just join both of them. I'm guessing that's not really the way they want you to do it. Really, we should only move. It'd be nice if we can just like, so A is A, if one gets to the next one, then we increase to the next one and start comparing. At every point, they must be equal because I definitely see a way that I think something like word1 dot join equals word2 dot join. I'm not saying this is a nice solution. I don't think this is the way that we should go about it. True, true. Let's see some of the other ones here. True, false, true, true, false, true. I mean, 97.91. So like when I see a question like this, I ask myself, you know, if I do this, it might show, hey, I know the language a little bit more and I'm making something that's like in the real world, right? This is the more practical solution, not coming up with whatever like crazy pointer logic we might need to be able to do that. But now it's 5, so it's obviously a lot worse. So I'm almost, I feel like the best solution would be to somehow, man, I really want to see the discussion just to see what they have to say. Else, yeah, like else I might do something that's like, let me take this last one here. I have A, B, C, D, and then this whole thing. So if I'm comparing these, let me just make some more room here. Let's say we have an I here, and then we have our J down here, right? I say, okay, I and J are the same, so increment it. I can increment it, both the same, increment it, both the same. Now, if at any point I come out of the bounds of it, maybe at that moment I'll get to the next thing in my array. I'll do this, both the same. Okay, come to the next thing in my array, increment, increment. So something like that. I think that could work. So let's see, what are the cases like iterate, sort of like one, iterate normally. I think two, if we are out of bounds and not at the end, change array index and reset to 0. Reset some incrementer logic to 0. This is like one thing I'm thinking of here. So how do we want to go about doing this? We're gonna need, let's say, let I equals 0. I can say let word1 index equals 0. Let word1 array index equals 0. Let word2 index equals 0, and let word2 array index equals 0. So we want to do this while what? Like at some point when I get here, both of these, yeah, we want to do it while both are valid, right? Because as long as we're incrementing them together, then they'll never not be valid, right? So as long as, no, actually not I, while the array indexes are valid. So while word1 array index is less than word1, word1's already an array, right? 0, 1, okay. So less than word1 dot length, and word array index 2 is less than word2 dot length. Now what is it we want to do? And this should be array index, word2 array index, word1 dot length, word2 dot length. Okay, cool. How do we start this now? Let's see, if, I guess we don't really, we can always just say if word1 at word1 array index, so at word1 at 0 at word1 index does not equal this whole thing again for word2. Word2 array index, word2 index. Here we can just return false, right? If word, let's see, if word1 index, if it equals the length, can't you just toString the whole arrays? I did that. That's what I did up here. So that's a fantastic question. I really appreciate that question. So I did that up here, and I do agree like this would be the more practical answer. But sometimes I'm like, do I like is this the question that an interviewer want? Is this the answer that an interviewer wants to see, or do they want me to come up with something, I guess, more complex? I mean, maybe not. Maybe I'll look at the discussion and everyone just did a simple join, but I just want to sort of mess around with this and see what we can get. If word1.index is greater than, or if it's equal to, I can't see on my phone. Yeah, no, I know. I'm really like, I'm truly sorry for that because there isn't like an elegant way for me to stream this to mobile users because At least for me, I haven't used LeetCode on my phone before, and I don't think it'd be very nice to watch on the phone. Although I do know that the majority of people use the Reddit app on mobile. So sort of like what I've been doing, and this is really just the best time for me to say this, but what I do is for all these streams, I upload all these videos to my YouTube channel. Simpler than better. I agree. Yeah. I'm probably just gonna mess with it for a couple more minutes and see just for fun at this point. But I've been putting all these streams on my YouTube channel, and I literally have like this first video that's like, oh, LeetCode accountability stream number one, start here. And the intent with this is that you can go from having solved no LeetCode questions and watching all these streams, and together, like myself and viewers will solve a ton of questions together and hopefully learn from it and get better. So don't worry too much if you're not able to see it now. I do put all this stuff on my YouTube channel, so you can always watch it at your own pace later. I linked to the channel earlier in the chat. I'll do it again. That way, hopefully it didn't get lost in there. Oh, wow, that was loud. Hopefully it doesn't get lost in the stream chat, but I linked to my YouTube channel again there if you want to see it for yourself. And yeah, hope to see you there and we can all learn together and get better at this stuff. So if word1 index is greater than word1, or if it's greater than word1 array dot length, then I think we can do word1 index equals 0 and this plus plus. And then I think we can also do if word1 index. Sweet, I'll check it out. Hey, thank you so much. That's awesome. Yeah, I really appreciate that. I hope you can go on there. Like I've been struggling with LeetCode for a long time, and this has worked wonders for my own improvement, and I truly hope that it works for people watching it too. I feel like because I've been there, I know what I know like where I can add value so that viewers can hopefully benefit from it. So, okay, if this is that, that's that. If they're not equal, else we should just be able to increment both of them. And then here, can we just return true? Very interested to see if any of this will work. Let's remove all this and let's comment this out. And let's just freaking see this for fun. False, false, false. It's beautiful. Okay, if word1 at 0, word1 index 0 is not equal to word2 at 0, word2 index. So it's not, oh, wait, you can't actually, let me look at this again, right? Because we should be able to do, like, if word1, which is this, at 0, which is this, at 0, okay, if that's not equal to word2 at 0, 0, return false. Okay, that's not the case. But now we say if this is greater than or equal to word1 array index, let me see, word1, no, wait, why am I doing word, word1 array index? It should be, yeah, this is getting crazy here. This should be word1. Yeah, if it's greater than the thing that we're currently on. Wow, there's going to be a crazy amount of variables here. Yeah, if this thing just starts getting crazy, I might just, maybe it's better to not even do it. And then this is word2. This is one of those that like, because of this, it's very easy to get into errors. Again, false, false, false. So word1 at 0 dot length, word1 index. So we just finished the first one. Let me pull this out. Okay. So if 0 is greater than or equal to word1 at 0 dot length, no, it's not. If word 2 dot index, okay, and then increase both of them b. Oh, I see. I think probably maybe I should do this check. Maybe I should do this check before comparing them, just in case they're not, just in case they're not in the right places. Let's check this out. Okay, line 26. And now I didn't like this one, word 1 index. Okay, and then it gets here, undefined, reading 0. Do we need maybe like another check? Because if I'm ever doing this, maybe this can just be true. Or let's see, we can do something like if, okay, not equal to false. If, let's say this, let's see, if word1 array.index is greater than or equal to dot length, or greater than or equal to word2 dot length, return false, perhaps. Still false, false, false. Okay. Yeah, I think at this point, just for the sake of the stream and how complex this is looking, I'm I really want to see if, because that we know that join works, right? It works. Seems like it has decent time, but let's see what people have to say. There you go. Java using count pointers, no string concatenation, 4 pointers, and iterator solution. Yeah, doing it in no one space is the trick. That's definitely the trick. That's definitely something that we need to try and do. So because of this, I'm gonna add it. I have a list of somewhere here. I have this list. So what I'm planning to do with this list is like maybe once a week on Saturdays, I'll revisit all the questions that I have on this list and see if we can come up with better ways. But yeah, like this is the easy way out, I guess, right? But you can do it in constant space by using that 4 pointer. And I think the 4 pointers, I see that 4 pointer technique a lot. So it's probably really good to learn it. I definitely want to revisit this. And I think we were so close. I think we were close, but it's okay. Let's get to the next one. Minimum bit flips to convert a number. All right. A bit flip of a number x is choosing a bit in the binary representation of x and flipping it from either 0 to 1 or 1 to 0. For example, x equals 7, 1, 1, 1, and we may choose any bit, including any leading zeros not shown, and flip it, okay? We can flip the first bit from the right, flip the fifth bit from the right, okay? Given two integers start and goal, return the minimum number of bit flips to convert start to goal. Only because, okay, this is interesting. Let us think about this here. This is going to be crazy. So we have 1, 1, 1, which is 7. And I'm going to put a 0 up here because to make 10, we need an 8 and a 2, right? So this is 10 right here. So this reminds me kind of there's like a medium question having to do something with like locks. And I think, I'm sure there's like an easy way to do this, but I almost want to say that it might be like a breadth first search, minimum bit flips to convert the number. Because like, what would this, if I were to draw this out as a graph, so we're trying to get from start to goal. Let's do, what is it, Excalidraw? Let's delete this, confirm. We're trying to get from 1, 0, 1, 0. So if I think about this, man, I hope that people on the phone can see this because at least when I draw things out is how I benefit enough from it. 1010. Like how many options do we have here? We have a couple, right? We have like four different things that we can do. So let me draw those out. Let me actually not even. Let's do 1, 2, 3, 4. Let's get that arrow. Let's do this. So it's like for each one of these. So at 1010, let's say we flip the 0 here, 0010. Here it would be 1110. Here would be 1000, and here it would be 101011. This is like how we're flipping each one. And now I think like from here we want to get to what? To 3? To 7. Are any of these 7 so far? None of them are 7, right? So do we just now I'm gonna have to draw a lot of circles here because now I'll need like another 4. What would be the best way to go though? Because we need 0, 1, 1, 1. 0, 1, 1, 1. I feel like we probably should go down this path. So let's see what this gives us. Can I pan here? To move canvas, hold mouse wheel. Oh, great. I'll put this up here so we can draw some more circles up here. Let's do another 4. I know this is not going to look very nice, but this is me theorizing. So I don't know too much about graph algorithms or graph traversal in the sense of like why they should be used. I know how to do them most of the time, but why? And I recently learned that BFS is really good for shortest path. And I think that's what we're trying to find, like the least amount of numbers or the shortest path to get to 0, 1, 1, 1. So like here, if we flipped all the digits, we would get we could do like 1, 0, 1, 0. Oh, wait a second. No, 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 no. We don't want to do we don't want to do that again because that would, well, 0, 1, 0, 1, 1, 0. Oh, okay. 0, 0, 0, 1 or 0, 0, 1, 1. So if we went this route, we can do 0, 1, 1, 0, 0, 0, 1, 0, or here we can do 0, 1, 1, 1, right? Here we can also do 0, like this will get us there or this will get us there. So I almost feel like okay, let's say we go down, like if I go down this path here, I'm gonna draw 4 more circles here again. I know the arrows are crazy, but just bear with me. I think this is something that we can do. And then here we'd have 1, 1, 1, 0. Here we can have 0, 0, 1, 0. Here we can do 0, 1, 0, 1, 0, 0. Wait, 0, 1, 0, 0. Or we can do 0, 1, 1, 1. So I almost think like, right? How many, like what are the 1, 2, 3? Yeah, like how many is it ed is it edges? Yeah, how many edges are there to the goal? There's 3. And if we look back here, it's 3. Now it's just a matter of like figuring that out. So I guess like for each one, I don't want to like when do I or I guess I just stop immediately whenever I get to the number, we just stop. And we always visit like so let's say like if this is my graph and I start doing it, let's sort of do what BFS would do, right? It'd be nice if I can label these nodes in some other way. Can I color this? Can we make this yellow or like orange? Let's do like a, okay. So I think the answer is like here to here to here. That's what I think the answer is. Something like this. And if we were to label all these, it should be nice if we could. There's not like a very easy way, so I'm just gonna use it based on the number, right? So we have an array, we get to 1, 0, 1, 0, and now with breadth first search, we explore all the children first. So let's pop this off. Let's put all the children 0, 0, 1, 0, 1, 1, 1, 0, 1, 0, 0, 0, or 1, 0, 1, 1. Okay, and now we pop this one and put its children, which would be 1, 0, 1, 0, 0, 1, 1, 0, 0, 0, 0, 1, or 0, 0, 1, 1. Cool. And then we pop this guy off, and then we have same thing. So like 1, 1, 1, 0, 0, 0, 1, 0, 0, 1, 0, 0, and 0, 1, 1, 1. And we say, hey, like this is the answer. So we essentially did it in three pops, right? We did one, we popped that one off, we added all the children. We popped another one, added all the children. Popped another one, added all the children, and that's when we got it. So I think it's like every time we pop, like pop all the children, that's one. Pop, add all the children, that's another one. Pop, add all the children, then we get to our answer. So yeah, I think this pattern right here, it's a breadth first search to try and find the the solution here. Now I got to think about how it's like a nice way for me to generate all these. I mean, could we just I don't want to have to create like a string every time. There's probably a much easier way to do that. Like create, like the children will just be, and like how many bits, right? I don't love that we got to do it start at 3 and it's 4 binary representation. We have to deal with binary numbers and what's the 10 to 9? Like, how do we know? Let's remove this one. Let's remove this one. Like representing this is always a little bit of the tricky part. What is the most significant bit and how can I generate other numbers? Let's see if there's like a pattern here. If I flip one of these, like this is 10 and it goes to 2 and then 9, 8. Okay, yeah, I don't really see a pattern there. Hmm, maybe it doesn't. No, I definitely should generate all four of them first. Each individual bit. And also what's the size of each one of these numbers? A bit flip, I mean 10 to the 9, but that's wild. That's like a very big number. And the minimum of bit flips to convert from start to goal. Can we just account? Well, what is 10? No, 10 to the 9 is huge. 10 to the 9 to binary, or like binary representation, decimal to binary converter. How many numbers deep do I want to go? That's the part that I'm stuck on right now. Like I've definitely drawn this thing out. I know what I have to do. Now it's a problem of converting like this number and flipping each one of these bits individually. And maybe that's not even flipping it either a bit and either from, including any leading zeros not shown, and flip it. Minimum number of bit flips to convert start to goal. This might be something I want to look this up. Like MDN, not MDM, like how many set bits in a not like what or get most significant bit of a number. Is there like a trick to that? Oh, this is Oh, this is actually, wow, that's funny. That's an actual problem. Could use bit shifting. Oh, the number is not equal to 0. I really wish there was just one way to do it. Built-in function, GCC. Oh, I see. Yeah, that makes sense. We can just keep shifting it over by 1 until it falls off, and I'll just make it a 0. But that's still not, I don't want to have to calculate that every single time. All these bits have been shifted. If I push a 1 in here, 1, 1, 0, 1. I push a 1 from the right, it'll be 0, 1, 0, 1. 0, 0, 1, 0. Flip flip every bit of a number. Not flipping. Putting all 32. Or we can just also go, could we just, while doing that, generate to mask it with after the fact? Yeah, there's a couple steps here that I think I'm gonna need to like work this out because maybe, yeah, I guess the mask we can do flip bits. I'll flip all of them to use the k least significant bits. So you want at least one bit, of course. That's why math starts at 1. All the bit using operations. I feel like we can do something like this. Like for each, we have a number. I generate all the flipped versions of it while, yeah. So where am I stuck? Just so everyone knows. If I have this number 10, it's like I want to go just like starting from here, but the thing is there can be like many, many, many zeros here. I don't want to also do all this stuff, right? I just want to go to the most significant bit. That would be really nice if I just generated 4, only because it's that big. That's sort of like where I am right now. And right, because there could be like a 1 all the way over here. So how many times do you need to do it? Would it be the same if I generated all the bits here and then shifted it, generated all the bits? No. Up until, flip all bits up until, like flip bits until most significant bit. Toggle all bits after most significant bits, including the most significant bit. So toggle bits until most significant bit. Toggle bits. How do I set clear shift bit manipulation? Toggle all bits except after highest set bit. Input expected. We can do the following. Code result n equals, so n is equal to that, n to v equals 1, while v is less than or equal to n. v1 1 result equals n. So like, would something like this work? Can we just like print this out and see what this would look like? Can I convert this to some JavaScript real quick? So let's say let's start equals 10 while v is less than or equal to n. Oh, and n is the number, right? Yeah, so let's say let v equals to 1 while v is less than or equal to start. int result is n, or can we just do console log of n b minus 1, and then b, like there's no, like, is this question actually, is this like that bit manipulation heavy, this question? I suspect it's not. I almost feel like I'm definitely making this harder than it needs to be. Log of n, this is start. That's gonna go on forever. nb minus 1. Purpose is to set the following. Yeah, we're gonna, like, for anyone watching, what I truly hope helped you is this graph, because we spent quite a lot of time on this question. So I'm gonna move on to the next one. I'm gonna put this one, I'm gonna add it to my list, but definitely, yeah, we definitely need to revisit that one. Count the number of consistent strings. That was a fantastic question. Actually, let me go back to it and save it, because we know how to do it. We know how this graph is constructed. Now it's a matter of generating the children of every individual node. That's a great takeaway, I think. So great question. You're given a string allowed consisting of distinct characters and an array of string words. A string is consistent if all the characters in the string appear in the string allowed. So let me see. So allowed, let's see, if we always have the frequency in this string allowed, so string is consistent if all the characters in string, wait, string is consistent if all the characters in the string appear in the word allowed. Strings AAAB and BAA are consistent since they only contain characters A and B. Okay, so let me see. That one's consistent. That one's consistent. Oh, okay. So, okay. I think what we're doing, I'm learning so much. Thank you. Oh man, that is so great to hear. That is amazing. Man, that's like literally a random useless guy. I wish I can, like, I don't even know how to send awards through stream, but I'm gonna have to link up with you after and see if I can do that. Literally, the reason I'm doing this stream is for that right there. That's amazing. I'm so happy that you're learning a lot. And if you are on the phone, I know it's hard to see, but I promise you I'm gonna upload this to my YouTube channel afterwards. I'll link up with you after the stream, and I can send you a link directly to the channel. And that way you'll be able to see this, full screen at your own pace. Don't have to worry about anything. For anyone that's hearing me, and if I sound weird, it's because I'm using a headset, and I'm getting enough into this that I ordered a mic, and I'm happy to like increase the quality of my stream as we go along to have like a better viewing experience for all you. So that's awesome. Thanks again. And yeah, let's keep going. So I think really what's happening here is, like, as long as all the characters in here are in allowed, then it's fine. As soon as we get to one that it's not, we can just skip over to the next one. If we've made it to the end of the current one without that happening, then that's true. Um, you know what though? We can really take advantage of some JavaScript here, and let's see if we can make it happen. So can allowed have duplicates? Okay, so it's all distinct. Let's see. I want to create allowed set equals new set. I think I should be able to do this. So I'm spreading allowed, so I get an array. So I get an array of characters, and then I'm making that my set. So let's see if, let me just make sure that works. So const set, well, let's do const word equals ABC. Const set equals new set of word. And then set is ABC. Okay, cool. So I think what we can do, output 2. Oh man, this we can really make this like wild right here. We can reduce, we can do words dot reduce. So here we have an accumulator and a value. We're going to start off with 0. My value is going to be the current word, and really, if, let's see, if for every character in value, so if val, oh, can we do every on a string? I don't know if we can. MDN array prototype every? No, we can't. Check every string. Check, let's do string every JavaScript array.prototype. Hmm. We really could do something crazy here. We can say const word array equals array dot from val. Oh, wait. No, we can do something better. If, right, this will give us an array. If val dot every v dot allowed set dot has v, we can return act plus 1 or return. I will explain all this once I'm done. Right now, honestly, this is mostly like a fun thing. 2 274 274. Does that work? Wow. Okay. That's crazy, but that's cool. Let me explain what happened, right? So we have this question here, A, B is allowed. Really what we want to do is for each one of these words, we just want to make sure that every character exists in here. So this has an A, that's an allowed, but D is not, so we automatically just reject the rest of this. B, D, so I guess here I'm losing some time because I'm still checking every single thing, I think. I don't know if this terminates early. Maybe that's something that MD and every, do we know if this thing terminates early? Oh, nice. If such an element is found, the every method immediately returns false. So that's cool. Like we are, like this method is returning early for us, so we don't even have to go through every array or everything inside of the array. So we get to here, B is inside of allowed, D is not, so terminate. A is in there, A is in there, A is in there, B is in there, great. B, A, and then same thing here. B is there, A is there, D is not there, terminate, that's fine. So we create a set so that way anytime we're looking for one of these, it's a constant time. It happens in constant time, right? When we're trying to find something in a set. Then we want to reduce this whole array of words into a single value. So that's what I'm using. I'm using words.reduce and I'm giving it an initial value of 0. And our accumulator is just going to be starting at 0. That's the thing that will increase depending on our condition. And the value in this case will be our word, which really here, instead of using val, I can say word. Here I can say word. And then for every car, let's say, so it's a little bit more clear, what are we doing? Here we do a spread operator, which will make the word into an array because the every method only works on arrays. So here we're saying if every character in my word is inside of my set, then we know that we can return accumulator plus 1. Else, we just return accumulator plus 0. And I know there's probably like a better way of doing this. We can do, let's see, we could say return, I can do, if this is true, you can say act plus 1, else act plus 0. Let's see what this gives us here. Run code. 274, 274, does that still run? Okay, that still runs. And I think we can do, I wonder if like, can I do return act plus Does this work? Is that 1, 1? Okay, so I can't actually do that. What if I do um act plus? Yeah, I think now I'm trying to get too like concise, which definitely which typically is not very like good. I can remove this return here. I can remove this guy, and this guy here. Make this a little more condensed. See if this works. 274, 274. What is it that we end up with? 93.69. So I'm pretty happy with this. If we think about the time and space complexity, we have like the time to create a set. Let's actually look up time complexity of creating a set. Time complexity for set creation in JavaScript. So that's O of n, right? To create that, we're doing O of n, and then for every word, we're doing at the worst of O. So this is actually this is quadratic time. So is there a way? I think I'm gonna have to go through. I'm gonna have to go through each one of these words anyway. So I think quadratic time will win. Let's see what the discussion has to say. Linear fastest solution, Python one line, bit manipulation. Oh, wait a second. No, no, no. It's not. It's not actually. It's not quadratic time, right? It's it's m times n, where m is the size of words, and then this is the size of the length of each one. Linear. All the words are valid. Bear with me. Some crazy bitwise manipulation, maybe. 74 cases passed, fastest to date. Okay, let's see. C++, all of. Nice. Python one line. Oh, see, this is not helpful. Java using hash set. I came up with something very similar. Consistent plus plus. See, like, is this, I think set search, log n time if I'm not wrong, perhaps unordered set. Well, I think MDN set time complexity, MDN set, yeah, 6 map. I think the V8 implementation, yeah, O of 1, ordered hash tables implemented. So I like my solution. Again, I think I truly hope that interviewers not like today are not expecting these like bitwise manipulation questions. Let me see. A couple variables. So for example, if you had allowed equals bef, you'd have, oh wait, this is not doing bitwise. What am I talking about? I saw the ones and zeros, and that's automatically what I think about. Let's see what this says. A result variable that we set equal to the length of words. Okay. 26 Boolean characters. Allowed normalized to b, subtracting a. For example, if you had allowed equals bef, you would have alpha as bef. Then we loop through each word in words and then go through each character C in each word. We decrease res, one less valid word, and break. Oh, interesting. Like if you ever get one that's 0, then you can just break out of there immediately. True. Okay. Yeah, I think this is definitely good. Something that we can, it's something good to think about. Using, again, let's see, is there allowed length? Yeah, this is again one of those things. I think like if you ask yourself, hey, like allowed length is 26, words at I dot length is 10. These are like some very clear bounds, which might help you come up with very strict like space constraints, I guess. You can create just like an alphabet array. You can create some other words array that are always bounded, like doesn't matter the size of the inputs. So I think paying attention to these is important. Let me refresh. I know we started the stream with 40 questions. So let me see how we're doing. We've only done, no, there's no way we've only done 42. Did we spend that much time in the other ones? Count number of pairs is absolute. Check two. Oh, we've done three, but this one was a recap of yesterday. Okay, two lowercase. Okay, given the string s, return the string after replacing every uppercase letter with the same lowercase letter. Okay, so is this only going to be s dot length is less than 100? S consists of printable ASCII characters. So anytime I'm dealing with strings in JavaScript, you need to realize, or if you don't already know, strings are immutable in JavaScript. And one really cool way to find that out is, let's see if we can emulate this real quick. So let's my string equals hello world. So there should be get own property descriptor of my string. That's undefined. Does that not returned? Oh, get own property descriptors of my string. Okay, so something very, very cool. If you don't know what property descriptors are, or like object descriptors in JavaScript, they're essentially like a more advanced way of configuring an object. So each one of these properties, right, like everything, well, you may have heard the term everything is an object in JavaScript. And if you think about it, like this is just an object where each one of the keys just has like a value, right? Like key 0 has a value of H, key 1 has a value of E, so on and so forth. If we read here, we see that all these, like each one of these keys, configurable and writable, are false. That's why you can't actually change a character in a string in JavaScript like you could in like C++, for example, right? So if we look at this MDN property descriptor, I do want to see if we can see what each one of these means. Configurable. So when configurable is false, it cannot be changed between data property and accessor property. When enumerable is true, then you can see it when enumerating over the object, which in this case we want to normally print out the characters in a string. And writable is if the value associated with the property may be changed with an assignment operator. So just quick like JavaScript lesson there. This is why, like for this one, what I'm immediately going to do is I'll create like a copy of S, right? So now I have an array that's a copy of this S string that we get, right? So what I can do for really each one of these is I think we can just we can map over each one, and then at the end I want to join it because I want to make it back to a string. So I'm going to put map here, but then with the array that we get back, I'll just join it. Now we really got to figure this out. So we're going to map over each C, which is our character. And what do we want to do? We first need to figure out if it's uppercase. Easiest way to do this is we can say const character code. This is equal to c.charCode at 0. What charCode at 0 does is it just gets the character code at a specific index of the string that you gave it. So in here, for example, this is just a single character, so we just want the character code at the thing that's in position 0. And then from here, we can figure out if it's uppercase or lowercase. So let's defer to an ASCII table. And this is going to help us decide. So we know that capital A is 65, and that goes up until Z, which is at 90. So it's uppercase if it's between 65 and 90. So if character code is greater than or equal to 65, and character code is less than or equal to 90, then we go ahead and we transform it. I think the way we can do it, so if we have a 65, which is an A, and I want to go to the lowercase a, I can add, what, 22? 32. 75, 85, 95. Yeah, so 65 plus 32 gives us 97, and 97 becomes the decimal value of the A code. And the nice thing is that here we can return string dot from car code. I think here we can just do character code plus 32, or we just return C. Let me see what this gives us. Hello, hello. Ran too many. I'm spoiled here. Hello, here, lovely. Let's run this. 95.03. Okay, so this is pretty cool, like nice way of doing it. So the map comes in very handy here. We start off by creating a copy of our input string, because remember in JavaScript, these strings are immutable, so we can't alter them. Create a copy, and now we're going to map over every character in the copy. And we can get the character code by using this car code at method right here. If that's greater than or equal to 65 or less than or equal to 90, we know it's an uppercase character, and we figured out from the ASCII table that if we add 32, then we get the corresponding lowercase character. And string.fromCarCode, just like it says, will generate a new string based on a car code. So we can just return this, else we'll just go ahead and return the C that we already have. And for anyone out there that, if you really want to be condensed here, you could do return. You can use a ternary here. I know people love to do things like this. Not always extremely readable, but makes the code look sexier. That's what people like. Hello here, lovely. Let's submit this. Yeah, so I'm pretty happy with this. We have, I guess we can say that the space complexity, since we have to create a new array, is O of n, where n is the amount of characters in S. And the time complexity is also linear, since we're just having to traverse through our whole input string. So I typically like to keep these capped to around an hour. Let me see what the next question is. See if we can get to that one. I don't want to rush through it if I believe it's like going to be too crazy. Let's see. There are n rings, and each ring is either red, green, or blue. The rings are distributed across 10 rods labeled from 0 to 9. You're given the string rings of length 2n that describes the n rings that are placed into the rods. Every two characters in rings forms a colored position pair. First character of the ith pair denotes the ith ring's color. Second character denotes the rod. Okay. So red placed in 3, green placed in 2, blue placed in 1. Okay. Return the number of rods that have all 3 colors of rings on them. So B, okay, so blue goes on 0, and then blue goes on 6, green goes on 0, red goes on 6, red goes on 0, red goes on 6, G goes on 9. And then we can probably just, let me see. Blue interface rod, return number have all 3 colors of rings on them. So we go blue, blue 6, green goes to 0, red goes to 6. If we already have one of those, yeah. So I almost see. Let's see. This doesn't seem like too bad, but I want to keep like maybe like a set at each location, and that tells me the characters that I have. So anytime I put a blue in 0. Okay. Well, let's just go through it, right? We have how many rings? 0 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We go through our input array here. And we really could just do this once, right? We can say our count is equal to 0. So we put a B at 0. Then we put a B at 6. So anytime we put it, we calculate it and say, do we currently have 3? And if we do, we can increment our count. Green goes at 0. Red goes at 6. Red goes at 0. We have a 3, so count is 1. Red goes at 6. But there's already a red, so we don't add anything. G goes at 9. So we only have 1. So I think that's a way to do it here. Yeah, I think we can do, let's do let count equals 0. Also create a rings map, const rings map is just object literal. For let I equal 0, I less than rings dot length, I plus plus, I less than rings dot length minus 1. That way we can get both things. So let's say const ring color equals rings at I, and const ring position equals rings at I plus 1. So we want to try and put the, let's see, if, so let's say if I go to the ring position, so if rings map at ring position equals undefined, so this is like the first time we've gone through it. Undefined means like this is the first time we're going to put something in it. Let's create a new set at that position. Rings map at ring position is equal to a new set. And then here we can say rings map at rings position dot add. Do I want to say, yeah, ring color. Let me actually go through this. So I less than rings dot length, ring color is rings I, ring position. So if rings map at ring position, which is 0, is undefined, and we can say at 0 we put a new set, and then rings map at 0 we add blue. Okay, cool. And now here we can say if, let me just look at the API first, set mdn set. The API for this, what is the one that gives me, is it count or size? Size gives me the amount. So if rings map here dot size equals 3, then we can say count plus plus, and then we can return count. Let's see if this works. We have 1 and 1, 1 4 0, 1 1 0. Okay, so this next one right here. Let's see. So why are we getting 4 for that next one? Example 2. Must be something. I'm guessing there's something I didn't consider here. Okay, so 0 1 2 3 4 5 6 7 8 9. Or wait, do we have? Okay, it's always 0 to 9. Okay, so blue goes at 0. Here we have a blue. Red goes at 0. Green goes at 0. Red goes at 9. Red goes at 0. Oh, if we've already, we're like double counting, right? That's what we're doing. We're double counting. Is there any way that we can get? What if I like reset it at that moment? Can we do that? Is that, because is there any way that I might have like six? Oh yeah, we had it only once. Wait, the rod labeled 0 holds 6 rings with all colors. The rod labeled 9 holds only a red ring. So maybe instead of doing this, what we can do is maybe we can iterate, like we can do another thing here. We can say for const, let's see, our key is going to be position and then colors of object dot entries of rings map. And I guess here, as long as it's a multiple of 3, we can add 1. So const position color of object entries. Object entries returns to you an array that contains, for each item in here, it contains a key and a value. Key and a value. So we're using array destructuring here to say, instead of calling this key and value, I'm giving it better names. and make it easier to read the algorithm. So for const position and color of object entries, we can say, or I guess colors, right? Well, it's never gonna have, yeah, I think if colors dot length equals 3, or if colors dot size equals 3, count plus plus. So will this work? Let's test this out. 110, 110, submit. Okay, interesting. Let's see, since I'm in it now, let's see if we can't figure it out. We'll give it like one more shot here and see what happens. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's go through this. So we have a G at 3, we have an R at 3, we have an R at 7, we have a B at 7, we have an R at 5, we have a B at 1, we have a G at 8, we have a G at 4, we have a B at 3, we have a G at 6. So what happened here? Because this should only give me, so this right here is not working, right? Add ring color, GRB, ring color for const position. For key value, my value should be the set of rings map. What are we actually getting if I do console, oh man, console.log colors? I thought that would be my set. Let me comment this out. We have the colors. Let's copy this one because I want to see this as a test case. Let's run this. Right? Oh, wait, what? 37754. What? Oh, plus or equals 2 up here. I think, right. Let's see. Count plus plus. Let's get all test cases. Let's copy this one. Use example test cases plus the new one. 3, okay, so even worse. Oh man. If colors dot size equals 3, count plus plus. 1101, 1101. Is this one gonna work? 96.59. Okay, sweet. So yeah, that was also a pretty cool question. I wonder if if we're, let's see, so we have count and rings map. Do I really need, I don't need my rings to be, we could just create a 0 marked through what? If I give it a length of 10, right? Like new array of 10. How can we check rings color 0 through 9? Rings map, rings positions, new set. So if rings map, rings position equals undefined, then we create a new set there, and then at that set we add ring color. And then for the object entries, now we don't need to do this anymore. So for const C, for const color set of rings map, now this is just an array. Size, count plus plus, does this still work? Did I ruin it? If color set dot size const color set of rings map. Maybe we should do for let I equals 0, I less than rings map dot length I plus plus const color set equals rings map at I if colors set dot size equals 3 count plus plus. Rings map at I. Oh, no, yeah, that's fine. Rings map at ring position. Oh, it's because this won't be, it's not actually undefined. If I fill it with undefined. So if you just create an array without using fill, it'll create empty slots, which are not the same as undefined. And it still didn't like that. Rings map at ring position is equal to undefined. Create a new set. Rings dot length. If rings map at ring position at 0 is undefined, we'll create a new set there. Rings map at ring position. So what does rings map have? Console.log rings map. Whoa. Okay. Oh, wait. Why is it printing out so many? I should only have new set ring at 0. BGR 0 has every single thing. Ring color, ring position. It should only be happening once. Rings map is new array of 10. Fill with undefined. If rings map at ring position, which let's say for some example here, 0 is undefined, then rings map at 0 is a new set, and then rings map at 0 to that set, we add rings color. Oh, wait. Rings map. Here it's because I'm printing rings map every single time. Still get way more than I would like. So that's pretty crazy. Why are we getting so many here? Rings map dot length, fill undefined. Console.log, we're adding a new set. And how many do we end up with? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, BRG, 12, 13, 14, 15. Don't know where we're getting all that from. Console.log ring position. At this moment, I'm just debugging. I'll spend like a minute or two more on this and then might wrap up the stream here for now. So 0606069. Okay. When I go to 0, this is the set. When I iterate through this, I less than rings map dot length. Console.log, whatever it is at. Maybe it's because color set rings map at I, color set dot size equals 3 count plus plus. I really don't know why that wouldn't work. This is a set. The thing that's there is a set. Interesting. Well, I think we got to like the bulk of the question and we were able to figure it out. Now I just have to see how far back I can go here. I think we ended up on here, maybe. So we ended up creating a map that was where the key is the position and the value is a set. So let's see what discussions have to say. A bit mass counter. East solution, add it to the color array. Okay, all three rings are present. Make three arrays for every color. That's cool. Bitwise array of sets, bit mask counter. Code colors the bits 1 to 4 and use the OR operation for each rod. Return the number of rods that have all three bits set with the value of 7. Oh, that's pretty cool. Bit mask counter, yeah. It's just three like discrete values you can use. That's pretty awesome. C++ 100%, not that clever though. That's very cool. Nice. Sweet. So I'm gonna about wrap it up here. It's been an hour and 25 minutes, the longest stream to date. Just some quick notes real quick. I'm gonna follow up with Random Useless Guy and also Killer Tofu. If you guys are both watching, that's awesome. I'll follow up with you on Reddit so I can give you the link to this channel. But for anyone else that's watching this, I already have the link to the channel on the stream chat. So if you're interested in watching this stream as well as all the other ones that I've done, so that way we can all be on the same page, then feel free to join me. I'm looking very much forward to seeing all of you there. Thanks again for joining the stream. And I might come on a little bit later today because it's Friday and I just have more time since I'm not doing work. So happy coding, everyone. Later.